Hello everyone, welcome to Gyandeep, a channel where we talk everything about data science. Well, in the previous video, we in fact embarked on a new video series which will be focusing on the named entity recognition and relation extraction. This is the structure that we laid out. So we had covered the first two bullet points, essentially the understanding NER and relation extraction and data labeling for NER and RE using Label Studio. These two of the bullet points we covered in the previous video. If you have not watched it, please do watch it and then come back to this video. So in this particular video, the part 2, we'll be focusing on the custom NER using Spacy. So our focus would be essentially to take the Level Studio data that we generated in the bullet point 2 here and then build a Spacy model. This is the data, right? Let's get into the code. Started with the custom NER model using a Spacy. I'm using version 3.0.8 here, and the data has been annotated on Level Studio. This data is available on the Kaggle dataset. Okay, we start by importing the libraries here. So we import pandas, JSON, NumPy, Spacy, and then from Spacy dot training dot example, we import example. This one will hold the information for one training instance and we'll see its use later. Then we import random TQTM to check the progress, Spacy.scorer, and this one too. From here we import a scorer and it will help us compute the evaluation score. And finally we import the warnings. These are the labels which are present in the data set. So we have a PER, which essentially is the person related label, time, which is date and time related label, ORG, which is organization related label, LOC, which is location related label. Now, the next step for us is essentially to fetch the file name and essentially to convert the Label Studio data into the Spacy NER format. Okay, so Spacy ingests the data into a specific format while training, and we need to convert this Label Studio data in that format. So I'll give you a quick glimpse of the data. So here is my raw data. So this is how it looks like. So it has got sentences, sentence ID, and the text here. So sentence ID is an int here, and the text is a string. Thousands of demonstrators have marched to London, etc. And then if we see the data coming from Label Studio, it looks like this. The same first row that we saw. So it has got a sentence number which is int type 1 and the text is what we just saw, thousands of demonstrators, etc. And it has got multiple labels. Okay, so the first one is essentially uh, having these as the key values, start and text, and the text being London, and London is of the label type LOC. And then the second one is the start and text, and in this case, the text is Iraq, and the label is again the LOC. Third one is carrying the label of ORG. Okay, so then it has got some additional key values like annotator, annotation ID, created at, updated at, lead time. We are not much interested right now in these keys and the values, so we essentially will drop them. Okay, so this is how the data looked like. We'll go back to our editor. Okay, so now in order to convert, we'll first fetch the file name. So my file name is label underscore studio annotated JSON. We'll start by creating an empty list here, train underscore data, which is an empty list, and then we'll open the file. And for that, we need to do the JSON.load and since it is in the JSON format. Okay, so my training data is now this is essentially loaded with this JSON file here. Okay. Okay, then we fetch the, so we essentially iterate it over the training underscore data, right? And so for the text in the training underscore data, we create the entities, a list, empty list of the entities. We first pick the info, so we go do the text dot get text. So through the get method, we get the text from the data. Now we check for the label. So text dot get label. If that is not none, then only in that case we proceed. If there is no label assigned, then I would not want to consider it into my list. So if it is not none, then I essentially do an enumerate over text dot get label. Okay, so we saw that there are multiple labels there. Okay, so for the count of the label that is contained right in the in the particular text, it will give me the int and which is an integer component or the indicator here and the label. Now again we'll check if the label, right? So if that essentially is a none or an empty thing, right? Since we are manually annotating, so we'll be doing these all checks. If label dot get labels is not none, then only we proceed and we append to this empty list the label dot get a start, so it will pick the start value, end value, and it will also get the labels. Okay, so this way my data would be curated and train underscore data dot append. We do info entities. So entities here is the list of all start and text, start and an entity that's contained in for a particular text, right? For which essentially is nothing but the info here. Okay, so how does the train data look like? So if we are to see one of the items under the train data, so the first one essentially, so it would look like thousands of demonstrators and then all the entities will be contained under a list and will carry also the entity tag here. So like we see here LOC and OR. Okay, so now my data is curated, but even before I proceed to training a custom NER model, the next cell, I would want you to note that all these start and end positions are essentially here presented in such a way that they are not overlapping, right? So for this particular, the first entity here, LOC, it ends at 55 and position 55, and the second LOC starts at 77 and ends at 82, and then the third entity org starts at 111 and ends at 125. Now, suppose if there was a case where the third entity that we have on that would have started at say 77 itself and would have ended at 125. Hypothetical case. In that case, you would have stated that these entities are overlapping entities. LOC, the second entity that you see LOC, and the third entity, namely ORG, they are overlapping and we must get rid of the overlapping entities before we train a Spacy model. So in this case, the best way thing to do is either we drop the overlapping entities, the one with the smallest span, or we separate them out and train another model for the ones where the overlap happened. Right. So those are the two ways of dealing with it. Okay, so let's now proceed to rest of the code. So this is the training block here. We start by getting the pipelines ready. So it says that model is equal to none. So if model is not none, so in this case, obviously we have assigned model to be none. So it will not hold true. But then suppose we are into post-training phase and we want to pick the model which is already there in my disk. Then in that case, I would be essentially loading this model which might exist, and I'll define the path here. Okay, so in this case, it would essentially load the existing model, but then since model is equal to none, so it will skip to else, and it will do spacy dot blank en. So it will create a blank model of English type. Okay, so my NLP is a blank model which is created in this step, right? Now it says if NER not in NLP dot pipe names, NER is equal to NLP dot add pipe NER. So what it does is it checks whether the NLP dot pipe names it's containing NER pipe or not. If it is not containing, then it adds it. Okay. If not, if it is already containing, then my NER is essentially a specific pipe from the NLP model, which is of NER type. Okay, so that's what it will go to. Essentially, this step here, NLP dot get pipe, right? Unless we have removed or saw the NER earlier, this particular pipe, right? It will go to this step, the else related step. Okay, so now I'm ready with the pipes. Let's define the train test split here. Okay, so essentially it takes two arguments, data and the test. The test is essentially an integer value here. We can define it to be or give it to be any value like 10, 20, 40, 50, etc. So it will essentially fetch the position at which the train data should end, and we can use different kind of the functions or parameters to get the train end, right? Similarly, the train start test start, essentially this will be the one after the train end, so plus one, that's what we see here. And this will split the data, and data 0 to train end, and then data train end plus 1, then data, and will get us the train data and the test data. So that's what this function does, and gets us the train and the test data. If you see the len of train data, it's 20 here. So, and here we see that the train end has happened at 10. Now let's get to the exact modeling process. In this case, we define the train NER model, and this will essentially contain the data or the train data as one of the arguments, and we also need to pass the number of the iterations here, right? So for all the annotations that's there in the train data, it will then look for the entities in the annotations and will add to the NER pipe that we created earlier. Uh, One of the important things here is that we need to disable the pipes which are not of the NER type. So we pick those pipes in this step where we list all the other pipes that are present and are not of the NER type, right? And then we disable the pipes here with NLP dot disable pipes, other pipes, and we start the training here, NLP dot begin training, right? And then for each of the iteration, under the number of the iterations that we have defined, we shuffle the train data. So that's what is happening here, random dot shuffle train underscore data underscore m. We capture the loss here. So we start by initiating it to be an empty dictionary. And for text, comma annotations in train underscore data underscore m, we start by creating an NL in the document, the Spacy document type, right? NLP dot make underscore doc text. So this will convert the text into the Spacy document type, right? The DOC format. and then essentially we'll create the examples, right? So my example will be essentially an example dot from text, and it will contain the DOC, which is the Spacy document type, and the annotations that we saw for this particular document. For each of these steps, we'll be updating the model. So NLP dot update and example. It takes example as the argument. My losses will be updated here, and we have defined a drop to be zero point 0.2 just to avoid overfitting. Okay, so then we'll return the NLP here. Okay, so okay, fine. So we eventually get the NLP here. Now we'll start by training the model. So we do the NLP underscore model, train underscore and NER model, train underscore data. This was my data. And we iterate it over 200 of the iterations. So it could be your hypothetical number I have put in. It could be just based on the experiments, and you could record the values and could see how the losses actually tend to look like. Okay, so we see that the first one, it is started at 182 and my losses have decreased. I think it has really gone down till here, right? And after that, I think there is an up and down, so it sometimes increases or decreases, right? But then overall, I think it's less only, and so on. So we'll continue, we'll let it run till all the 200 of the iterations are over. Okay, so I think it will take a few more seconds before all the iterations are done, right? So I think it's done now. Okay, so my model training is over. So now in this case, now let's perform the testing on this model. So I've already done that for these many iterations, and I already have the results here. Let's give you a quick sneak peek of how it looks like when you actually go about performing it. So for whatever text we had in the text data, for each of the text, we again create the doc, which is of the doc using the NLP, right? NLP underscore text. NLP is what we got from here, if you remember. If you go up, and so this one essentially returned the NLP, right? So we come here back, and then we print the entities, right? So we have the end dot text and dot label for end in talk dot ends. So we have got the entities for each of the 10 test items that we had, right? So and then we will evaluate the score here. So before that, let me run this. Okay, so in this run, since we are doing the random dot shuffle, so that's why we have got some different result here. But anyways, we'll try to see and evaluate using the evaluate function. So the evaluate function takes NLP and the examples as the argument, and we create the initiate the scorer instance here. And example is an empty list here. Input and not in examples. We do the predictions basis whatever input is provided here, right? And this temp, which is now the example type, is then created here, right? And then we append the temp to the example, and we do the scoring here. So scorer dot score example, okay, which will match whatever is the prediction versus whatever is the goal data. Okay, so here we have the function ready for the is generating the scores, and okay, so we perform the results is equal to evaluate NLP test data, and here is the result. So in this case, to see the results, we essentially should look into ends per type, Now here we have got org related entities. So where P indicates for precision and R is for recall and F is for F1 score. So for org we got a precision of 0.66, R is 0.66, F is 0.66. For per the person related entity, the scores are really bad, almost zero accuracy there. For LOC, I think again P is zero point 0.5, R is 0.33, and FO is zero point 0.4. I think with more data, our accuracy will definitely improve and will definitely go beyond this. Okay, so this was the simple example to demonstrate how to build the custom NER model using Spacy 3.0.8 and Level Studio, right? Hope you liked it. I hope that you liked the video. In the next video, we'll be covering the NER models, custom NER model through the transformers. We'll also cover how you can add the transformers to the Spacy pipeline. Okay, so thanks for watching the video.